welcome back to the deep dive. Today, well, we're tackling something pretty fundamental. What really separates a star, our sun, from a massive planet like Jupiter.
Right. They seem vastly different, one glowing, one not.
Exactly. And our sources today explore something called motion theory. It's a different angle on this. Doesn't lean on the standard nuclear fusion explanation in quite the same way.
Yeah, it proposes a whole different mechanism, really.
So our mission, let's say, is to get our heads around how motion theory explains this difference, why stars shine, planets don't, and try to highlight the core ideas without getting lost in, super technical stuff.
There's a great line from one source to kick us off.
Oh, yeah.
The sun and Jupiter aren't that different until you realize one crossed the collapse line.
Ooh, okay. Collapse line. Let's definitely unpack that.
So maybe start with the standard view first, just briefly.
Good idea. Normally we hear, sun shines because its core is hot and dense enough for nuclear fusion, hydrogen to helium, releasing massive energy.
And Jupiter, it's big, but supposedly just not massive enough to kickstart that fusion process. It failed to ignite.
Right. But motion theory sort of flips that, doesn't it? It's not primarily about fusion ignition failure.
Not at all. It starts way more fundamental. It suggests reality isn't particles in a void, but structured rhythmic motion. Everything arises from that.
So things don't travel through space?
Not really. They resolve within this motion field. And gravity, it's not a pull. It's more like a convergence, a drift towards places with higher sync density.
Sync density, like more coordinated motion, more organized wiggling in one spot.
Kind of, yeah. More coherence in the underlying rhythm. And light, this is crucial. Light isn't just a byproduct of fusion.
What is it then?
It's the rhythmic collapse of that structured motion.
Whoa, okay. So applying that to stars. Why does the sun shine?
According to this theory, it's because the sheer amount of internal structured motion inside the sun, its internal loops, they cross a critical point, the sync collapse threshold.
The collapse line from the quote.
Exactly. The internal structured motion becomes too intense, too dense for the surface layers to maintain their stable, synchronized pattern. It's not burning fuel in the traditional sense.
It's a dynamic breakdown, a collapse of the structure itself.
Precisely. It triggers what the sources call the surface collapse principle. The high internal motion density overwhelms the surface sync stability.
And that collapse isn't chaotic.
No, that's the key.
Yeah.
The theory says it collapses and stabilizes into rhythmic radiation. That's the light, the UV, the X-rays we see.
And fusion, where does that fit in?
It's seen more as a consequence, a result of the extreme conditions created by this sync collapse, rather than the primary driver of the light itself.
Okay, that's a radically different picture for stars. So, Jupiter, what's its story in motion theory? It's huge. Massive magnetic field, right? Like 20,000 times Earth.
Absolutely huge. Which indicates, even in this theory, enormous internal structured motion. It's definitely not inert.
But no light. So,
crucially, its internal motion loops, however powerful, stayed below that critical surface collapse threshold.
Never crossed the line.
Never crossed the line. Jupiter is described as a giant structured motion system. It radiates heat, yes, because of that internal motion, but its surface synchronization holds. It never achieved that specific kind of stabilizing collapse that produces light.
So it's like simmering, but never boiling over into light emission.
That's a decent analogy. It's described as nearly ignited in this framework, but locked just below that collapse point, stable.
So the real difference isn't just mass, though mass obviously plays a role in building up that internal motion density.
Right, mass amplifies the internal density, but the make or break factor for shining like a star is crossing that specific threshold, the surface collapse threshold.
Making light a signature of motion collapse and stabilization, not necessarily fuel being burned.
Exactly. One source introduces the new principle, structured motion surface collapse. It basically says, light happens when internal sync density beats the outer motion stability, leading to this organized collapse in radiation.
So wrapping it up, stars are essentially structured motion collapse engines.
And planets are structured motion stability systems.
And Jupiter.
Jupiter's the fascinating case, sitting right on that edge. Almost a star, but fundamentally stable, like a planet in this view.
So going back to the start, the sun didn't so much catch fire as it crossed a motion threshold.
And Jupiter didn't fail to ignite. It successfully stabilized its motion before reaching that threshold.
The theory emphasizes inherent order, it seems.
Very much so. A quote sums it up. In motion theory, there are no accidents, only motion, rhythm, coherence, and collapse.
It leaves you thinking, doesn't it? Stars shine because, in a way, motion demands it at that scale. Planets survive because motion permits stability below that scale. Everything, maybe even us. Are we all just patterns dancing on this razor's edge of sync collapse?
A profound thought to end on. Definitely a deep dive into a different way of seeing the cosmos.